I'm Kiera Cavalleri.
And I'm Sonfist.
And our project was the geochemical analysis of high pressure, low temperature, and low pressure, low temperature metabasaltic rocks from the Motagua Fault Zone. Here's a map of the Motagua Fault Zone, which is highlighted by the red box and yellow arrow. And you may be wondering why this is important. It's a modern transform boundary in Central America between the North American and Caribbean plates.
Some may ask, why is the Motagua Fault Zone special? Well, it both has exotic Mesozoic metamorphic oceanic rocks as well as relative local Mesozoic continental rocks.
The exotic Mesozoic metamorphic oceanic rocks can be grouped into three belts. Belts 1 and 2 in the north, and then the third belt in the south. And these overtrust metamorphic continental rocks on both sides. And then these green dots highlight where we took our samples from.
These three belts contain low temperature, low pressure rocks, including metabasalts and microgarbo, which are low metamorphic oceanic rocks, as well as high pressure, low temperature rocks, including amphibolite and eclogite, which are subducted oceanic rocks.
Based on the high pressure, low temperature ages, three hypotheses have been proposed. The first hypothesis had two different suture zones, which was supported by argon-argon dating. The second had a single suture zone, which was supported by samarium-neodymium dating. And the third also had two suture zones, but this was supported by uranium-lead dating.
We developed a project that would allow us to determine which previous hypothesis was most accurate. And this included research in composition, tectonic origin, and tectonic history to tell us if there was one or two suture zones.
In order to determine composition, we used major elements, like here in our task diagram. From here we were able to determine that all were basaltic except for the blue schist. But we had to go even further than this. What kind of basalt did we have?
In order to answer this question, we used trace elements to tell us what kind of basalts are located in chart A and chart B show that the north of the Motagua Fault, belt 1 and 2, that they have iron-dark and normal oceanic crust. Chart C shows south of the Motagua Fault, belt 3, that has normal and enriched oceanic crust.
We created a tectonic scenario to support our data. In the north, there is a metamorphic passive margin and island arc and normal oceanic crust. Therefore, there will be an island arc passive margin collision scenario, making that suture zone 1.
There is also tectonic scenario 2 that represents the southern segment of the Motagua Fault Zone. It has metamorphic active margins and a normal and enriched oceanic crust. This will be an active margin seamount collision scenario, making suture zone 2. Therefore, there are two different suture zones.
And we would like to thank our mentor, Dr. Kennet Flores.
And also Brian and Sebastian for leading us through this great adventure.